Hello, I'm Matthew Macario from chemistrymadesimple.net. Today I'm going to talk to you about the numbers on the periodic table, that is, the numbers we see marked against each element. We're going to talk about what they are and how we will see them and in exam questions and how we can answer those questions. We're going to start by using the example of sodium. And on our periodic table we'll see that sodium has two numbers marked, like all elements do, and for sodium these numbers are 11 and 23. You will always see a smaller number and a larger number. So the smaller number 11, what does that mean? Well, that's the atomic number. Sometimes you see that labelled as Z, but we usually refer to it as the atomic number. What's that mean? That's the number of protons in each atom of sodium. And in fact, that defines, the atomic number defines an element. So in this case, if there's 11 protons, that defines our atom as being a sodium atom. That means that every atom that exists that has exactly 11 protons is a sodium atom, and that every sodium atom that exists has exactly 11 protons. How about the other number, 23? What's that? Well, that's the mass number. That's our total number of particles in the nucleus of the atom. That means the total number of neutrons and protons. Both of those are in the nucleus of each atom. And these are the particles in an atom that give it its mass, and therefore that's why we call this the mass number. So for sodium, there are 23 neutrons and protons together in the nucleus. So in summary, our atomic number, the smaller number, is our number of protons, and the larger number, our mass number, is the total number of neutrons and protons together. So what will we use these for? We'd be asked to use these in calculations in an exam. And one of the questions we would possibly be asked is to calculate the number of neutrons in an atom. So we're going to look at our example of sodium. And we're going to try and calculate the number of neutrons in here from the information that we can see in front of us now. So the number of neutrons equals the mass number minus the atomic number. Why is that? Well, the atomic number is a number of protons, and the mass number is a total number of protons and neutrons. So if we subtract the atomic number, the number of protons, from the mass number, we'll be left with the number of neutrons. So for our example, the number of neutrons is 23 minus 11. It's the neutrons plus protons minus the protons. So we have 12 neutrons in this atom of sodium. How about for iron? If we just pick an example from the periodic table, so we can see we have 56 and 26 marked on this. We would just refer to the periodic table that we're given with our exam paper in order to find that information. So again, the number of neutrons equals the mass number minus the atomic number. So for our iron 56, that's 56 is the mass number, 26 is the atomic number, which means there's 30 neutrons in this iron atom. So for this example, we haven't been told what the element is. That would be a giveaway, but we've been told the mass number is 7. And if we're trying to work out the number of protons, we know that that equals the mass number minus the number of neutrons. So for our atom, which we're also told has 4 neutrons, we can see that the number of protons equals 7 minus 4, the number of neutrons. So we have 3 protons. So we have 3 protons. We might also be asked, what element is that? So how would we know which element it is? We know that the atomic number is the number of protons. We know that the number of protons is 3. So lithium has atomic number 3. So this is the lithium atom. Let's try for another element. So in this case, we have the information that our mass number is 40 and there are 22 neutrons. So we calculate the number of protons to be 18. We know the atomic number equals number of protons, therefore we know that the atomic number is 18, and we can look on the periodic table and see that argon has the atomic number 18. But so far, we've only seen whole numbers on the examples we've looked at. So 26 here is the atomic number. That's the number of protons, and that will always be the same for every iron atom. But the mass number 56 can change. So if you look on your periodic table, depending on how many decimal places are used, you might see 55.8 or something similar. So the mass number is usually not a whole number on the periodic table, unless you're using a very simplified periodic table. And that's because of isotopes. And we're going to talk about isotopes in another video, so if you want to go over and watch that, it'll just be another few minutes to explain what we mean by isotopes and how it is that we don't always have a whole number for the mass number. So if you have a question and you'd like to see a video on a short topic, you can DM me at Chemistry Made Simple on Instagram, and you can also subscribe to me there, or subscribe to my YouTube channel, or go to my website at chemistrymadesimple.net. Look forward to seeing you.